Hello again. In this lesson, we're gonna continue with the L'Hopital rules, guys. You were wondering about the L'Hopital rules. Of course, L'Hopital rule is another rule we can use to get the limit of the sequences. And then, okay, let's state what the L'Hopital rule is, and then how I can use the L'Hopital rules for the sequences. You learned the L'Hopitals for the functions before, right? And of course, sequences are functions, but since they are not the continuous, you cannot use the L'Hopital rules directly. That's why, okay, we have a connection theorem between the sequence and the functions, and then this theorem is going to be about that connection point. So what it says, look at that, suppose that, let's say, okay, I have a function, f of x, and that function is defined for all x points bigger than n, and I'm gonna need that sequences, right, for this connection. N is a sequence of real numbers, and this is the connection point between this function and the sequences. And functions, the function is equal to the sequence at these points. Under this assumption, I can show it to you. Of course, we are not going to prove it. I can show it to you. If the limit of f of x is equal L, then the limit of my sequence, okay, is gonna be L as well. Why? Since I know, look at that, function is equal to the sequence at these points, of course, if the function goes, the L, which is the part of that function, you can see as a subset of the axis. Of course, it needs to go the same way, right? So we're not going to prove this theorem, of course, but we are going to use the result of this theorem, guys. Okay. But so of course you can ask, okay, what's the relation between this theorem and the L'Hopital rules? We're going to see in the examples. Basically, what this theorem says, you need to choose a function, right, which it is equal to the sequence at those points. If you have such a function, then you can use the L'Hopital rules. Otherwise, you cannot use the L'Hopital rules, since L'Hopital rules were given about the functions. Sequences are functions, but they are not continuous. That's why, okay, you cannot use L'Hopital rules. Why? If they are not continuous, you cannot take the derivative. To be able to use the L'Hopital rules, of course, you need to take the derivative of the given function. That's why we need to connect the sequences by the functions so that I can use the L'Hopital rules. Okay, as a first example, look at this one. Limit n goes infinite, 3n squared plus 5n over 5n cubed minus 7. So that's my problem. You will remember, we solved the similar problems like this one. We solved this using just the sum of the algebraic features and then 1 over n limit. But this time, what I will do, I will choose a function, which I know, this function is equal to the sequence at those points. The function basically is going to be same, but the only difference, I will use x values instead of n values. The difference, I know x values are continuous values, but the n values are the discrete values. That's why I can't use the L'Hopital rule directly. So look at that. If this is my f of x, now I can ask this question instead of the limit of sequence question. So what is the limit of this function when x goes infinite. 3x squared plus 5x over 5x cubed minus 7. Okay, let me try to take the limit of this function. If you look at the numerator, when x goes infinite, 3x squared plus 5x will go infinite. And then the bottom part will do the same as well. So infinite over infinite. I don't know what the infinite over infinite is since it is undefined. And then what I'm asking, how can I get rid of the infinite over infinite result? So can I use L'Hopital's? Yes, we can use the L'Hopital under these two cases, guys. You can use the L'Hopital, okay, if you have one of these, 0 or 0. If you had, okay, different type of undefined case, you cannot just use the L'Hopital rules immediately, okay. I will solve another problem, which I will show, okay, why you can't use the L'Hopital directly. You need to use some other technique so that you can get one of these cases to be able to use the L'Hopital. Okay, so I have one of these cases, and then it will allow me to use the L'Hopital rule. L'Hopital or L'Hospital, okay, whatever term, whatever name you wanna use. So if that's the case, if the result is one of these, the L'Hopital rule says you need to take the derivative of the numerator, which is 6x plus 5, and you need to take the derivative of the denominator, which is equal 15x squared. And you can take the limit of this new sequence or this new function, okay? So I can see this as still as a sequence, but I needed to switch by a function. One more time, I'm gonna try to take the limit. When x goes infinite, look at this, still I have the infinite over infinite result, right? And then that tells me, I need to use the L'Hopital rules again. So one more time, I'm gonna be using the L'Hospital rule. And so I will do the same thing. Take the derivative of the numerator, which is going to be 6. Take the derivative of the denominator, which is going to be 30x. Now, I'm going to ask the same question. What is the limit of this function? When x goes infinite, 6 over 30x is going to be 0. And then now I can complete my problem saying, since the theorem was saying, if the function of the limit of the function is L, the limit of the sequence is going to be the same number. So I can finish my problem by saying the limit of an is equal to 0. Okay, that's how I am using the L'Hopital rules once I have the undefined case. Another example. Limit when n goes infinite, ln n over n. Okay, when I solve this type of problem, first I need to see, what's going on here. When n goes infinite, look at the problem. ln n goes infinite, How do I know that? If you look at the graph of the ln function, this is a picture of ln n, ln n will do something like that, When n goes infinite from here, ln n will go to infinite. So infinite, when n goes infinite, n goes infinite. As you see, I have a similar situation as in the previous example. Infinite over infinite, I don't know what it is. That's why I can't use the main limit theorem directly, I need to use the L'Hopital rule if I can use. So to do that, I will do this. I'm going to choose a function, which is ln x over x, and then I'm going to work on this one instead of my sequences. And I will try to use my L'Hopital rule since I had the infinite over infinite. I'm going to use the L'Hopital rules, and I need to take the limit of these two terms. The limit of the ln x is going to be equal 1 over x, and then the